Picture this. You step out of your apartment in New York City, grab a quick coffee, and by the time you finish your drink, you're touching down in London. Sounds like science fiction? Well, welcome to the future of hypersonic travel. Imagine the vast possibilities when crossing the Atlantic becomes as routine as your morning commute. This groundbreaking technology promises to revolutionize how we perceive distance and time, shrinking our world in ways we've only dreamed about. But what exactly does this mean for our global transportation systems? How will it change the way we connect, trade, and explore cultures a world apart? In this video, we'll dive into the cutting-edge technological advances making this futuristic travel a possibility, uncover the potential impacts on our daily lives and global economy, and ponder the future implications of living in a world where distance is no longer a barrier. Join us on this exhilarating journey as we explore the rise of hypersonic travel and its potential to transform global transportation. Now turning to the origins of hypersonic travel, let's journey back to its roots in military applications. Initially developed for defense purposes, hypersonic technology was aimed at creating missiles capable of reaching unprecedented speeds. The need for speed led to significant advancements in materials and aerodynamics, laying the groundwork for what would eventually become the dawn of hypersonic flight. During these early stages, the military's focus was on achieving unparalleled velocity and altitude, crucial for strategic advantages. As interest in hypersonic capabilities grew, engineers began exploring the possibility of extending these innovations to civilian uses, sparking a shift in vision from defense to public transport. This transformation was fueled by breakthroughs in materials science and engineering, which were essential in overcoming the intense heat and pressure encountered at hypersonic speeds. As Professor John Hartson, a leading aerospace engineer, explains, the real game changer was developing materials that withstand extreme conditions without compromising safety or performance. These new materials include lightweight composites and advanced ceramics that provide the necessary durability and heat resistance. The engineering marvels behind hypersonic flight rely on cutting-edge propulsion systems like scramjets, short for supersonic combustion ramjets. These engines allow for sustained hypersonic speeds by maintaining efficient combustion even at high velocities. This technological leap has made it feasible to consider adapting hypersonic travel for civilian transportation, sparking interest in both the public and private sectors. Entering the current state of hypersonic travel, various companies and space agencies are racing to make commercial hypersonic flight a reality. Projects like the Stratoffly demonstrate the potential for hypersonic passenger aircraft capable of cutting travel times dramatically. Imagine a journey from New York to Sydney in just a few hours. As these possibilities become increasingly attainable, the civilian applications of hypersonic travel could revolutionize global transportation. Beyond trimming down travel times, hypersonic technology promises to reshape airline business models, redefine connectivity across continents, and spur innovation in airport infrastructure. As the sun rises on this next chapter of transportation history, the question remains, how soon will we see hypersonic travel as a part of our everyday lives? With ongoing research and development, the horizon appears promising, and the age of hypersonic travel is on the brink of transforming how we move around the globe. Moving forward, let's delve into the technological marvels that are making hypersonic travel a reality. At the heart of this transformation lie advanced propulsion systems, most notably the scramjet engine. Unlike conventional jet engines that require mechanical compressors, scramjets operate efficiently at high speeds by compressing incoming air through the engine's forward motion. This allows them to maintain efficient combustion at speeds that would traditionally be impossible, propelling vehicles at hypersonic velocities with ease. These cutting-edge systems are supported by groundbreaking materials engineering. hypersonic travel presents a unique challenge. The heat generated at such high speeds can reach upwards of 1,800 degrees Fahrenheit, enough to melt traditional aircraft materials. Enter heat-resistant materials such as advanced ceramics and lightweight composites, which provide the essential durability and resilience needed to withstand these extreme conditions without compromising safety. Companies and space agencies worldwide are racing to harness these innovations for commercial use. For instance, Stratoffly, a prominent project by a European consortium, is developing a hypersonic aircraft that promises to revolutionize long-haul travel. Meanwhile, in the United States, NASA and several private firms are making strides with similar ambitions, aiming to cut travel times in half and redefine the passenger experience. These initiatives are paving the way for a new era in aviation, but they also come with their share of logistical challenges. As we peer over the horizon, the logistical and infrastructural demands of hypersonic travel come into sharper focus. Traditional airports are not equipped to handle the unique requirements of hypersonic aircraft, necessitating a re-evaluation of runway designs, fueling stations, and maintenance facilities. The noise and sonic booms associated with such speeds also present environmental and regulatory hurdles that must be addressed to ensure seamless integration into existing air traffic systems. As the technological frontier expands, so too does the need to balance innovation with practicality. The journey to hypersonic travel is as much about overcoming these infrastructural challenges as it is about developing the technology itself. As the sun rises on this vibrant chapter of human ingenuity, the spirit of exploration propels us forward, setting the stage for the next wave of challenges that will define the future of transportation. As the next challenge unfolds, let us delve deeper into the obstacles that the commercial application of hypersonic travel must overcome. One of the primary hurdles is safety. The incredible speeds achieved by hypersonic vehicles mean that the margin for error is significantly reduced. Even minor technical glitches can have severe consequences, necessitating the development of fail-safe systems and protocols to mitigate risks and ensure passenger safety. Several industry experts emphasize the need for stringent testing and robust safety measures, akin to those used in the development of space travel technologies. Cost is another formidable barrier. The investment required to develop, test, and operate hypersonic aircraft is substantial. Research, materials, specialized technologies, and infrastructure all contribute to the steep expenses. These costs must be managed carefully to make hypersonic travel viable for commercial airlines and affordable for passengers. Innovators in the field are actively seeking solutions to reduce expenses, such as refining manufacturing processes and exploring alternative funding models. Infrastructural requirements present additional challenges. Current airport designs are outdated for accommodating hypersonic aircraft, necessitating the reimagining of runways, terminals, and support facilities. The development of specialized maintenance hubs and fueling stations is essential to support the unique demands of these advanced vehicles. Furthermore, the impact of sonic booms on communities near travel corridors is a significant concern. Mitigating the disruptive effects of these booms is crucial for gaining public acceptance and regulatory approval. Environmental considerations also demand attention. The high speeds of hypersonic travel result in considerable fuel consumption and emissions, raising concerns about environmental sustainability. Researchers are investigating the use of alternative fuels and more efficient propulsion systems to minimize the ecological footprint. This represents an ongoing area of study with potential breakthroughs lying on the horizon. As we stride toward this new era, the importance of balancing innovation with practicality and responsibility cannot be understated. The quest to make hypersonic travel a reality is not just about technological triumphs, but also about ensuring these advancements harmonize with societal expectations and environmental responsibilities. By addressing these challenges, the vision of a future where hypersonic travel becomes commonplace invites us to ponder a world reshaped by bold, visionary transportation methods. Moving forward, let us visualize the transformative impacts that hypersonic travel could have on global transportation. Imagine a world where crossing continents is as quick and routine as a short-haul flight. This technology could drastically reduce travel times, enabling passengers to journey from New York to Tokyo in just a matter of hours. Such speed not only redefines convenience but also reshapes airline business models. Airlines might pivot from traditional hub-and-spoke models to more point-to-point routes, streamlining operations and reducing layover times significantly. The implications extend beyond just reducing hours spent in the air. They might also redefine what we consider feasible for business meetings, vacations, or even daily commutes across continents. In terms of global commerce, the potential is equally profound. With the ability to transport goods faster than ever before, industries could see a surge in the efficiency of supply chains. Time-sensitive industries such as pharmaceuticals, fresh produce, and high-tech components could particularly benefit as products would reach markets in record time. This could foster growth in international trade and even bring about the creation of new markets driven by the demand for faster delivery. The tourism industry stands to experience a renaissance of sorts as exotic destinations become accessible in half the time. Imagine a weekend getaway to Australia from Europe or a day trip to the Great Wall of China from the United States. This not only increases tourism revenue but also promotes cultural exchange on an unprecedented scale. The ease of access to distant cultures could lead to greater understanding and cooperation among nations, influencing global cultural dynamics. Let us consider a hypothetical scenario. A major global city like Dubai, already considered a hub in traditional air travel, could become the epicenter of hypersonic travel. This would not only boost its economy but also position it as a leading example of modern transportation, influencing other cities to follow suit. The ripple effect of such a transformation could extend to various sectors, including real estate, hospitality, and even education, as students could attend international universities without the constraints of long travel times. As we contemplate these changes, the potential economic implications become apparent. Faster travel could lead to heightened competition among airlines, pushing them to innovate further. Meanwhile, economies that embrace this new mode of transportation might see increased foreign investment and a boost in tourism. Hypersonic travel could serve as a catalyst for economic growth, encouraging nations to develop supportive infrastructure and policies. This vision of the future beckons not just a technological leap but a shift in how we interact globally, highlighting the profound and far-reaching consequences of embracing hypersonic travel as a norm. Now turning to the economic implications of hypersonic travel, we delve into a realm where speed meets commerce, opening doors to previously unimaginable opportunities. The advent of hypersonic transportation could usher in new markets and industries, reshaping the economic landscape significantly. As airlines seek to incorporate hypersonic travel into their fleets, the demand for specialized materials and technologies will soar, driving growth in sectors such as advanced composites and propulsion systems. This burgeoning demand could catalyze a broad spectrum of industries, from aerospace engineering to supply chain logistics, nurturing a thriving ecosystem centered around speedy travel. For airlines, the cost implications are both a challenge and an opportunity. While initial investments in hypersonic technology may be substantial, the long-term benefits could outweigh these costs. Hypersonic aircraft may reduce operational expenses by minimizing the time planes spend in the sky, thus lowering maintenance and staffing needs. However, these savings come with the pressure to innovate and streamline operations, pushing airlines to rethink traditional aviation models. Travelers, on the other hand, might initially face higher ticket prices due to the novelty and exclusivity of hypersonic travel. Yet, as the technology matures and becomes more widespread, costs are likely to decrease, much like the evolution of commercial jet travel. Investment opportunities surrounding hypersonic travel are vast and varied. Futurists and economic analysts predict a surge in venture capital flowing into companies pioneering this technology. The race to develop efficient hypersonic routes could attract significant foreign investment, as countries aim to position themselves as leaders in this emerging field. However, investors must also navigate risks, including technological hurdles and regulatory challenges that could delay widespread implementation. These risks underscore the importance of strategic partnerships and innovation grants to foster collaboration and mitigate potential setbacks. As economies adapt to hypersonic travel, they could capitalize on opportunities by investing in supportive infrastructure, such as revamped airports equipped for rapid passenger processing and integrated multi-modal transport systems. Cities that embrace this evolution may experience economic boosts, becoming gateways to the hypersonic network and fostering an environment ripe for business growth and tourism. Additionally, regions that once lagged in connectivity might find themselves at the forefront of global trade, as proximity becomes less of a barrier. In this dynamic landscape, the symbiotic relationship between technology and economy becomes increasingly evident, underscoring the transformative power of hypersonic travel in reshaping our world. Moving forward, let's explore the environmental considerations of hypersonic travel. As we edge closer to the reality of ultra-fast travel, addressing the environmental challenges becomes imperative. Hypersonic travel, while promising unprecedented speed and efficiency, also brings with it significant environmental concerns. The high fuel consumption needed to propel these aircraft at such speeds is a primary challenge. At hypersonic velocities, the energy demands are immense, leading to increased greenhouse gas emissions. This presents a critical issue as the aviation sector already faces pressure to reduce its carbon footprint. Addressing this demand is not merely an industry concern but a global imperative as we strive to combat climate change and preserve our planet. To mitigate these environmental impacts, researchers are actively exploring innovative solutions. One promising avenue is the development of alternative fuels such as biofuels or synthetic fuels, which emit fewer pollutants than traditional jet fuels. Additionally, advances in propulsion systems, particularly scramjets, aim to improve fuel efficiency by optimizing combustion processes. These technologies hold the potential to reduce emissions significantly, making hypersonic travel more sustainable. Moreover, the design of hypersonic aircraft is evolving, with a focus on lightweight materials and aerodynamic efficiency to minimize drag and fuel consumption. These innovations highlight the industry's commitment to marrying speed with sustainability, ensuring that progress does not come at the expense of our environment. Regulatory bodies play a crucial role in shaping the environmental standards for hypersonic travel. As this technology advances, international aviation organizations are tasked with developing comprehensive guidelines to manage its environmental impact. These regulations must balance innovation with responsibility, setting clear limits on emissions and encouraging the adoption of cleaner technologies. Cooperation between governments, industry players, and environmental advocates is essential to create a regulatory framework that supports sustainable growth. By fostering collaboration and incentivizing green technologies, regulatory bodies can help ensure that hypersonic travel aligns with global environmental goals. As we consider the environmental footprint of hypersonic travel, it is important to keep in mind that the journey towards sustainability is ongoing. Emerging technologies and innovative regulatory approaches offer hope for a future where hypersonic travel coexists harmoniously with our planet's well-being. This consideration sets the stage for discussing public perception and societal impact, as we delve into how individuals and communities view these environmental challenges and the broader implications of embracing such transformative modes of transportation. Now turning to public perception and societal impact, we delve into the complex interplay between public enthusiasm and apprehension surrounding hypersonic travel. This revolutionary form of transportation promises to redefine our world, stirring excitement about unprecedented possibilities. Imagine reaching distant lands in the time it takes to watch a movie. Such convenience is thrilling, yet it brings to light genuine concerns over safety and environmental impact, as previously discussed. The public's response to these advancements is crucial because widespread adoption hinges on societal acceptance and trust. The readiness of society to embrace hypersonic travel depends on various factors, including cultural adaptability and technological literacy. Transitioning to such a fast-paced mode of travel requires an openness to change and an understanding of the technology's benefits and limitations. In many ways, society's ability to adapt to these rapid changes will dictate the speed at which hypersonic travel is integrated into our daily lives. Cities and communities will need to rethink infrastructure, travel norms, and even economic models to accommodate and capitalize on the benefits that hypersonic travel can bring. Experts suggest that managing public expectations is essential for a smooth societal transition. Communication strategies that emphasize transparency in safety measures and environmental commitments are key. Providing clear, consistent information about the safety protocols and sustainability efforts in place can help build public trust. Moreover, engaging in dialogues with communities to address concerns and answer questions can facilitate acceptance and reduce resistance. By involving the public in these conversations, stakeholders can foster a sense of ownership and partnership in this technological evolution. Society's preparation for this technological shift also involves educational initiatives that enhance understanding and skills related to hypersonic travel. These initiatives might include educational programs that explain the science behind hypersonic technology, its potential impacts, and how it fits into broader transportation ecosystems. By empowering individuals with knowledge, we can encourage a more informed public that is better equipped to navigate and contribute to this new transport paradigm. Ultimately, the path to integrating hypersonic travel into society requires a delicate balance between innovation and public sentiment. As we stand on the brink of this transformative era, efforts to nurture a positive perception and readiness for change are vital. Through collaborative approaches that marry technological advancement with societal needs, we can pave the way for a seamless transition into a future where hypersonic travel not only exists but thrives as a cornerstone of global transportation. With anticipation for what's to come, we now move forward to envision the future landscape of global travel, exploring scenarios where hypersonic travel becomes an integral part of our everyday lives. As the sun rises on the next chapter of global transportation, envision a world where hypersonic travel is not just a marvel of the future but an integral part of our daily lives. Imagine a scenario where interconnected multimodal transportation systems seamlessly blend traditional travel methods with ultra-fast hypersonic flights. This integration could transform the way we move, connecting airports, rail stations, and urban transit networks into a cohesive, efficient web of global mobility. Futurists and technology experts are already outlining the potential for hubs specifically designed for hypersonic travel. These futuristic hubs would serve as central points where passengers could swiftly transition between transportation modes, minimizing delays and maximizing efficiency. Imagine arriving at one such hub in a major city and smoothly transferring from a hypersonic flight to a local transit system in mere moments. This could redefine convenience and flexibility in travel, fostering increased global connectivity. The socio-economic impacts of such hubs could be profound. Cities with advanced hypersonic hubs could see a surge in economic growth as they become focal points for business and tourism. The increase in global accessibility may open up new markets and opportunities, allowing even remote regions to engage more fully in the global economy. This could lead to a redistribution of economic power, with regions previously considered isolated gaining prominence on the global stage. Forecasts suggest that the infrastructure supporting hypersonic travel would need to evolve significantly to accommodate these changes. The construction of new hubs and the adaptation of existing infrastructures would require substantial investments, potentially creating a myriad of jobs and stimulating economies. However, these advancements would also necessitate detailed planning to address challenges such as land use, environmental concerns, and community impacts. As we contemplate these possibilities, it becomes clear that robust policy and regulatory frameworks will be essential to support this evolution. International cooperation will be crucial in shaping policies that ensure safety, fairness, and sustainability in hypersonic travel. Such frameworks would need to address everything from airspace regulations to environmental standards, ensuring that the benefits of hypersonic travel are enjoyed equitably and responsibly. With the future landscape of travel evolving before our eyes, we stand at the threshold of a new era in global transportation. As these visions take shape, they offer a tantalizing glimpse of a world where travel is faster, more connected, and more accessible than ever before. As we delve into the policy and regulatory considerations next, we prepare to explore how such forward-thinking solutions can help us navigate this promising yet challenging journey into the future of travel. With the next phase of the journey in sight, let's examine the crucial role that international regulations and policies will play in the realm of hypersonic travel. In the rush to embrace this groundbreaking technology, ensuring the safety and efficiency of hypersonic travel relies heavily on a well-structured regulatory framework. Existing aviation regulations designed for traditional air travel will require significant updates to accommodate the unique challenges and opportunities presented by hypersonic travel. Airspace will need to be managed more dynamically, with new criteria for flight path planning and traffic control to avoid congestion and ensure safety at speeds previously unimaginable in commercial aviation. Moreover, the speed and altitude at which hypersonic vehicles operate present a fresh set of considerations for international regulators. The current standards for aircraft noise, emissions, and environmental impacts are aligned with subsonic and supersonic travel, which means they may not fully address the peculiarities of hypersonic flight. This technological leap necessitates a collective effort to forge new, comprehensive standards that address these specific challenges. International cooperation will be a cornerstone in this endeavor. Bodies like the International Civil Aviation Organization will undoubtedly play a pivotal role in unifying efforts across nations to establish consistent rules and practices. These efforts include everything from developing shared safety protocols to fostering agreements on airspace usage, ensuring that hypersonic travel is not only feasible but also equitable and sustainable on a global scale. In addition to technical and safety considerations, regulatory frameworks must also address economic factors to promote fair competition. As countries and companies vie for leadership in hypersonic travel, policies must ensure a level playing field. This could involve regulating market entry conditions, pricing strategies, and subsidies to prevent monopolistic practices while encouraging innovation and collaboration. One of the larger challenges will be balancing the pace of technological advancement with the often slower process of regulatory development. Policymakers will need to be forward-thinking, crafting adaptable regulations that can evolve alongside technological progress. This will likely require close collaboration with industry experts, scientists, and stakeholders to anticipate future developments and prepare for them today. As we stand on the brink of this new frontier, the world is watching how regulations will shape the future of hypersonic travel. These frameworks will not only define how safely and efficiently we travel, but also influence the degree to which hypersonic travel becomes a widespread reality. By creating robust, flexible, and fair regulations, we can ensure that the benefits of this extraordinary advancement are shared globally, paving the way for a future where hypersonic travel becomes a standard rather than an exception. As we look to the preparations needed for this hypersonic future, the importance of strategic investments in education, technology, and infrastructure becomes increasingly clear, aligning our present actions with the promise of tomorrow's travel landscape. As the next challenge unfolds, the preparations for a hypersonic future extend beyond regulatory frameworks into the realms of education, technology, and infrastructure. Businesses, governments, and individuals alike have critical roles to play in this transformation, requiring proactive measures and strategic investments. For businesses, the emergence of hypersonic travel presents an opportunity not only to innovate but to spearhead advancements across their industries. Investing in research and development can help companies stay at the forefront of technological breakthroughs. Collaborations with research institutions can foster new technologies that improve safety, efficiency, and sustainability for hypersonic travel. Furthermore, businesses should explore new business models that capitalize on reduced travel times, such as faster logistics services or offering exclusive hypersonic travel packages. Governments, on the other hand, need to prioritize the development of infrastructure capable of supporting hypersonic technology. This includes enhancing airport facilities to handle the unique requirements of hypersonic vehicles and ensuring readiness to accommodate their specific needs. Investment in advanced air traffic management systems is crucial to maintain safety and efficiency as airspace becomes increasingly congested. Governments should also look to forge international partnerships that enable the sharing of knowledge and skills, allowing for a smoother integration of hypersonic travel into existing transportation networks. For individuals, the shift towards hypersonic travel signals a need for adaptability. Encouraging an education system that emphasizes science, technology, engineering, and mathematics will equip future generations with the skills necessary to engage with this cutting-edge technology. Individuals can also focus on gaining knowledge and expertise in fields that are likely to experience growth, such as aerospace engineering or sustainable technology development. Embracing continued learning and staying informed about technological trends will enable individuals to remain competitive in an evolving job market. Reflecting on these themes of innovation and adaptation, it becomes evident that the preparation for a hypersonic future is not confined to any single domain. It necessitates a collaborative approach where businesses, governments, and people unite to harness the potential of this technology. By aligning their efforts, they can contribute to a future where hypersonic travel is accessible, efficient, and beneficial for all. With the groundwork laid through strategic investments and cooperative efforts, the horizon of global transportation is set to expand remarkably. As we move forward, the anticipation of hypersonic travel becoming a standard mode of transport underscores the importance of innovation and adaptation in shaping a connected world, challenging us to embrace the future's possibilities actively. Moving forward, let's take a moment to reflect on the transformative potential of hypersonic travel. This incredible technology not only promises to reshape how we traverse the globe, but also to redefine the very fabric of global transportation. The advancements made in propulsion systems and materials science have paved the way for achieving unprecedented speeds that can drastically reduce travel times. Imagine crossing continents in the time it takes to enjoy your morning coffee. The economic possibilities are equally profound, from creating new markets and opportunities in the aviation and space industries to enabling a more interconnected global trade network. Hypersonic travel has the potential to unlock economic growth on a scale we've never seen before. Airlines might rethink their current models, potentially offering ultra-fast freight services or new luxury experiences that capitalize on reduced travel durations. However, the environmental considerations cannot be overlooked. As we look to the skies, we must also consider our impact on the Earth. The high fuel consumption and emissions associated with hypersonic travel pose significant challenges. Yet, these challenges drive innovation, compelling researchers to explore sustainable energy solutions and efficiency improvements that could benefit our planet. This brings us to the broader implications of hypersonic travel. It represents a shift towards a more connected world where distances are no longer a barrier. This could foster greater cultural exchange, enhance social interactions, and even redefine how we perceive global communities. As we envision this future, it provokes a crucial question. How can we ensure that this technological leap benefits all of humanity while preserving our environment for future generations? As we wrap up this exploration, consider how you might participate in this evolving narrative. The prospect of hypersonic travel is not just an industry concern but a societal one, inviting each of us to think about our roles and responsibilities in the face of such advancements. We encourage you to share your thoughts, engage with these ideas, and subscribe for more insights into the technologies shaping our world. By looking toward the horizon with curiosity and a spirit of innovation, we can collectively navigate the journey toward a future that embraces the wonders of hypersonic travel. Thank you for joining this exploration, and remember, the future is in your hands.